Okay, welcome everybody. Today we want to look at our review here for these tests on Chapter 7 sequences and series. Okay, let's go ahead and take a look at these examples then, or these practice problems. For numbers 1 through 3, we want to state if the sequences that we're looking at are arithmetic, geometric, or neither. Arithmetic would have a common difference, geometric would have a common ratio, and neither would have neither. All right, so 13, 7, 1, negative 5. If I look at this, I kind of think this has a common difference, okay? Because it's going down pretty steadily, okay? So let me take a look at what the common difference might be. So let me do the second term minus the first term, 7 minus 13, which is negative 6. So let's see, is it going down by negative 6 each time? 13 plus negative 6 is 7, of course. 7 plus negative 6 is 1. Yep, that works. 1 plus negative 6 is negative 5. All right, so yeah, number 1, we are definitely looking at an arithmetic sequence here. And it has a common difference of negative 6, which we found by taking the first term, taking the second term and subtracting the previous term. Let's take a look at the second example here. 2, negative 4, positive 10, negative 16. Okay, well, at first instinct, I don't think this is arithmetic because it's switching from negative to positive. It's going positive, negative, positive, negative. Okay, so maybe it's multiplying by a negative number. Maybe that's what's happening here. So if we take so maybe it's geometric. So let's take the second term, divide by the first term. So I know that it's being multiplied by negative 2. 2 times negative 2 is negative 4. Negative 4 times negative 2, that's supposed to be 8. But the number is 10. Okay, so it does not have a common ratio. It also does not have a common difference. This has neither. This is not any type of sequence that we know about, arithmetic or geometric. Let's take a look at number 3. Okay, number 3, 1/3, 1/9, 1/27. Well, this is definitely not arithmetic, okay, because it's just a fraction that's getting smaller and smaller. Let's check to see if it's geometric. We'll take the second term, a ninth, divide by the first term, a third. Okay, so you can put that in a calculator, or you can do a ninth times 3 over 1, because dividing by a fraction is multiplying by the reciprocal. So that's just 3 over 9. So the ratio might be a third. Okay, so 1/3 times 1/3, that's a ninth. Okay, fantastic. 1/9 times a third is 1/27. Okay, even better. So this is indeed geometric. We have a common ratio of a third, okay, because it's being multiplied by 1/3 each time. Write the rule for the given sequence. Okay, the rule is going to be the AN formula, the formula that determines each term in the sequence. Now, the AN formula is different based on whether this is arithmetic or geometric. So we have to look at the sequence to determine which one we're trying to use here. So 83, 79, 75, this is going down by 4 each time. We have a common difference of negative 4. Going down by 4 each time. So this is going to be arithmetic since we have a common difference. The formula for arithmetic is that the nth term is the first term plus the difference n minus 1 times. And we want the general rule for this, so that means it can be used to find any term. So we're going to substitute into this the first term, which is 83, and the difference is negative, so it's going to be minus 4, and n minus 1 times. Okay, now this formula is fine. As it is right now, it'll work, but I do want to simplify it. So the 2 steps to simplifying this, we will first distribute, then we will combine the like terms. So distributing, I'll put it down here. Distributing, we have 83, negative 4 times n, negative 4n, negative 4 times negative 1 is positive 4. Combine the like terms, 83 and 4, so we get negative 4n plus 87. So the nth term can be found by doing negative 4n plus 87. So that's the general rule for this sequence that can be used to find any specific term. Now we're actually going to need that for the next problem. The next problem wants us to find the 74th term in this sequence. Okay, now this can be done one of two ways. You can just take the first term and add the difference 73 times, or you can use this formula, which this formula is already, this is the same thing. In its case, this is the simplified form. So I'm going to just use the formula. So the 74th term, negative 4 times 74 plus 87. The other way you could do this is doing A74 is equal to the first term 83 plus the difference negative 4 73 times. Both of these are the same thing. This is just like the simplified version, okay? So they're both the same thing. All right, I just need to calculate this. So negative 4 times 74, negative 296, and negative 296 plus 87. Whoops. Negative 296 plus 87, negative 210. 74th term, negative 210. Is that what I have on the answer sheet? There's an answer sheet at the bottom here. Negative 209. What? Maybe I made a mistake when I made the formula. Negative 209? Negative 296 plus 87. Okay, let me make the formula again. Let me just double check. So let me use the other formula. So 83 minus the difference 73 times. It is negative 209. Okay, so what did I do to my formula? My formula must be wrong. When I simplified it, I must have made a mistake. So the first term, probably combined like terms wrong, or just wrote it down wrong. Minus 4 and minus 1. Not 4. What's my difference? Yeah, it is 4. It's going down by 4. Negative 4. So 83 minus 4n plus 4. Okay, so what am I doing wrong then? I just put it in the calculator wrong. This actually does come out. Okay, so I didn't make a mistake. I just put it in the calculator wrong. This actually does come out to negative 209. Okay, so not really sure how I put it in the calculator wrong. Negative 209. 74th term in the sequence is negative 209. I really don't want to start the video over because I made a mistake. So you're just going to have to deal with that. I did it both ways. Well, I did it a second ago. All right, let's take a look at number 6. A stadium has 15 seats in the first row, 15, 22 seats in the second row, 29 seats in the third row, and so on. There are 60 rows, so n is equal to 60, 60 rows. First, we want to know how many seats are there in the 60th row. Okay, easy. That's going to be the 60th term. Okay, so the 60th term can be found. We don't need to do the whole simplifying the equation thing, the rule. Okay, I'm just going to use the rule as normally. So I'm just going to take the first term and add the difference, which the difference here is 7. It's adding 7 each time. And I'm going to add that 59 times. because the 60 minus 1, so 7 times 59, add the 15, 428 seats in the 6th row. Let's check our answer, because now I'm paranoid. 428. Okay, fantastic. How many seats are in the entire stadium? Okay, so the entire stadium, that's the first row, plus the second row, plus the third row, all the way to the last row, which was 428. Okay, so we actually are doing a series here, so we have to use the series formula. So the series formula for, and this is arithmetic, it looks like this. Half the number of terms, and then multiplied by the first term and the last term, added together. So there are how many rows? 60. So we're doing 60 over 2. And the first row, there's 15 seats. The last row, there's 428 seats. Okay, so 60 over 2, that's 30. 15 plus 428 is 443. So we're looking at 30 times 443. 13,290 seats in the entire stadium. Check our answer, because yeah, 13,290. Fantastic. Wonderful. 13,290 seats in the entire... Okay, that didn't make it much better at all. There we go. All right, so we just did a series. We added all of the seats together. Number 7, write the rule. Okay, the rule is the AN. It's used to calculate a specific term. That's the rule. So we want to write the rule for number 7. Number 7 is a geometric sequence. This is geometric. The ratio is, it's being cut in half each time, so it's being multiplied by 1/2 each time. And you can find that by taking a term and dividing the previous term. 400 divided by 800 is a half. Okay, so the rule is pretty straightforward. It's the first term, which is 800, multiplied by the ratio to the n minus 1 times. And the geometric one doesn't need to be simplified. There's no simplification here. Okay, it just stays the way it is. So that's fine. Find the 8th term of the sequence. Okay, so A8 is equal to 800 times 1/2 to the 7th power. Since we're using a fraction here, I'm just going to use our Desmos calculator. So 800 times 1/2. That 1/2 is raised to the 7th power. We don't want this. We want this. 25 over 4 is the 8th term. Double check that. This is number 8. Yeah, 25 over 4. Wonderful. Number 9, write the rule for the sequence 2, 6, 18. All right, well, it's clearly geometric. It's being multiplied by 3 each time. The ratio is 3. So once again, same thing. The rule is equal to the first term 2 multiplied by the ratio 3 to the n minus 1 power. Find the 9th term. Okay, so an, or a9, is equal to 2 times 3 to the 8th power. 3 to the 8th power multiplied by 2, so 13,122. Whoops, 13,122. Too many 2's. Let's check number 10. Yeah, good. Number 11, find the sum of the geometric series. Okay, so this is a geometric series, the notation, proper notation for a series. We know it's geometric because it says so, but also it's multiplication. So we're going to need to use the formula for our geometric series. Okay, the sum is equal to the first term times 1 minus the ratio to the n power over 1 minus the ratio. We need the first term, which we can find the first term just by plugging n equals 1 into n. That gives us the first term. So 3 times 2 to the 1 minus 1. 3 times 2 to the 0, whoops. 2 to the 0 is just 1. Okay, so the first term we're starting at in our series is 3. The number of terms is 9, but you can just take the top number, we're ending at 9, subtract the bottom number, and add 1. So the number of terms we have is 9. We also need the ratio. The ratio is always going to be right under the exponent here, because this is the r value in the formula. So the ratio is 2. So we can set up our sum. So we have the first term 3 multiplied by 1 minus the ratio to the 9th power over 1 minus the ratio. Okay, let's put this into the calculator. So we had, it's a fraction, 3 is the first term, multiplied by 1 minus the ratio, which is 2. And that 2 is raised to the 9th power because we're looking for the 9th term. In the bottom is just 1 minus the ratio, 1533. Okay, so the sum is 1533, 1,533 for this sum right here. Let's check that. Number 11. All right, great, 1533. Number 12, this is an arithmetic series. So we're adding all the terms together. To do the arithmetic one, the sum of an arithmetic series, n over 2, the first term plus the last term. So first we need the number of terms, which is pretty straightforward. It's going from term 1 to term 12, but you can just subtract them and add 1, so it's 12. We need the first term, so we can just plug 1 into this. 2 times 1 plus 4, which is 2 plus 4, which is 6. First term is 6. We also need the term we're ending at, which is the 12th term. So we can just plug in 12. 2 times 12 plus 4, which is 24 plus 4, which is 28. The 12th term, is 28. Okay, now we can use our formula. We have everything we need. So it's equal to half the number of terms, 12 over 2, and then the first term plus the last term. Okay, so that's 6, and then 34. 6 times 34, 204 is our series. The sum of our terms is 204, number 12. Let's take a look. Yeah, 204. And number 13, we have how much would you have saved at the end of 20 days if you had set aside 25 cents on the first day, 75 cents on the second day, 225 on the third day, and so on. So this is geometric. The ratio is 3, being multiplied by 3 each time. And since we're saving money, we're going to have a total of all the days. So what we're actually doing is adding all of these days together. Plus. Okay, so this is actually a series, geometric series. So we have to use the series formula. So we need the first term, 25 cents, 1 minus the ratio to the 20th power, because we have 20 days, and then in the bottom, 1 minus the ratio. Okay, let's get out our calculator here. So in the numerator, we have 0.25 multiplied by 1 minus the ratio, which is 3. It's being multiplied by 3 each time, right? Yeah. And that's to the 20th power. The denominator, we have 1 minus 3. Okay, pretty big number. 435848050. $435 million? Is that correct? Yes, it is. So that's a lot of money, okay, because we're adding all of those massive numbers together. So it's $435 million, $848,050. So that's what we got there. All right, that's our last one there. All right, thanks for joining me.